Hi there, welcome to Raylene Maths. In this video we will look to see how to connect the standard and factored forms to the transformation form of a quadratic equation and the graph of a parabola. Given this example, y equals x squared minus 2x minus 15, we have the standard form. So a equal to 1 is positive, therefore the parabola is concave up and the same size as the parent quadratic. The c value, negative 15, also tells us that we have a y-intercept at 0, negative 15. So let's take a look at the graph, and from here we can compare the original parent function and the blue function, which is our transformed. The y-intercept's at negative 15, and the parent function goes left or right 1 space, up 1, left or right 2 spaces, up 2 squared, which is 4, left or right 3 spaces, up 3 squared, which is 9. This new blue graph does the same thing because we have the same a value. Left or right 1, up 1 squared, left or right 2, up 2 squared, which is 4, left or right 3, up 3 squared, which is 9, and so on. Now that we've confirmed that we've got the same size as the parent and the y-intercept, let's look back to the factored form to see if we can get the x intercepts of the parabola. So from the factored form, we have x plus 3 times x minus 5. This gives us two x-intercepts located at negative 3, 0 or 5, 0. We still see that a is equal to 1 because we have a coefficient in front of the brackets of 1. Once we take the mean of these two x-intercepts, we can get the equation for the axis of symmetry, x equal to 1. Then we can substitute that x value into either the standard or factored forms to get the y-coordinate of the vertex or the turning point. When we substitute into the blue equation or the green equation, we get negative 16. So our vertex or turning point is located at 1, negative 16. So let's turn on the green graph, which is the green factored form, and we can see that we've got x-intercepts located at negative 3, 0. We'll turn that one on, as well as at 5, 0. Then when we take the average or the mean of those two x-coordinates, we get the axis of symmetry line, which is x equal to 1. And so the factored form and the standard form indeed produce the same graph. We also know that we've got the turning point located at 1, negative 16, and now with the turning point coordinates and the value for a, we can get the equation of the parabola in transformation form. So the transformation form is y minus q equals a times x minus p all squared, where p, q represents the coordinates of the turning point. So when we substitute all three of those values, a, p, and q, we get y minus negative 16, which is y plus 16, equals 1 times x minus 1 all squared. We don't need to write the 1 in front of the brackets, and so then we can rearrange this equation to isolate for y, which is y equals x minus 1 all squared minus 16. I prefer the first version without isolating for y, but we can compare and make sure that both of those forms gives us the same parabola. So there's the transformation form, and there's the transformation form rearranged with the negative 16 on the right. Both forms produce the same parabola. So now that we see three different forms yielding different pieces of information about the parabola, our question is, how do we go directly from the standard to the transformational form? We'll find out in the next video. Thanks for checking out Raylene Maths.